Well, hello everyone. Today I'm going to explain to you the second session for the practical we are going to have in WSU Uni main campus. And actually this week we are going to cover two processes. The first one is going to be the writing the code for the chess part, and should be handwritten G code for the turning process. And the second one is going to be the G code generation using the solid cam. And then you have to take the code with you to the main campus and save that, which is going to help you to prepare the code for the machining process. Now first I'm going to do the G coding process. Actually I'm not going to make the part for you because it's going to be similar to the same tutorial I showed you last time for using the solid cam. But at the beginning you have to do the following, so you'll be able to generate solid cam which is going to be compatible with the machine we have in the main campus. You remember this part of the solid cam tutorial. First we're going to go to the view, the folder I uploaded last week. If you are going to click on this one, you will find three files: the FANUC PP, the FANUC PRP, and the FANUC VMID. You download these three files, then you go to the following link. It's going to be the C users, public documents, solid cam. Well, for the year, I'm not sure which version of solid cam you have, so you have to check that on the solid cam itself. Then you will change this number to, for example, to 2017. Then GPPT tool, you will open this folder, you copy the files you got from the view, these three files, and paste it on this folder. You'll get the message to ask you what to do. So okay, it will tell there's already a file with the same name on this location. What to do? I think you have to choose the copy and replace. Okay, so files, post processor. So this will enable you when you are going to use the machine in the solid cam, do the milling, the same process once again. The part here you are going to use the FANUC. Okay, so the machine is going to be the FANUC, and you are going to then do the same process for the same part we did in the assignment number 2, which is this one. Okay, I'm talking about okay, this part I gave it to you in the assignment number 2 simply because I don't want you to do it twice. You had the same part, you did the CAD cam for it. You have the file, you go once again to the lab, do the CAD cam, use the FANUC machine. Then after you're going to do the simulation process, the only thing you have to do is click. Instead of do the simulation, you are going to do the post-processing. Post-processing, and you're going to save the file as a G-code file. And it will look like a the text file. Save it on thumb drive or USB drive, and you have to take it with you to the main campus on Friday. Just pass it to save, and he's going to prepare the file for you so you can run it directly on the machine. And you're going to do the same part, which is going to be similar to where's the part? The 3D part. Oh, we don't have it here. Anyway, 3 part, you already know how it looks like. The one with the 2 pockets on the side, because you did what we call the mirror against the line in the middle. And you are going to be assigned against the machining of this part, how the accuracy you are going to have. Just remember something: when you're going to make the stock material, try to remove every offset from the outside. So you're going to have 0 for Z, X, and Y. Okay, now this is for the part 3 in the tutorial. Now once again you have to fill this sheet. For the student who already did the 2 previous sessions on the 2 Fridays we passed, I would like you to bring me the sheets we got for the PRAC 1 and PRAC 2. And today you are going to cover the other thing you are going to do, which is the turning G coding. How to do the CNC programming to make this part. Of course, you are not going to have these details at the top. You're only going to have the basic shape, which is going to be the top, we have an arc here, we have straight line, then we're going to have two level, big arc, and two grooves at the top. I'll try to do something similar. It shouldn't be exactly the same because you can see here that we don't have any dimensions. The most important thing now is going to be the stock material is 67 millimeter in height and 31 millimeter in at average diameter. You need to keep 17 millimeter considering we mount the rod in the chunk. Try to fully make the use of the material. Appropriate tool will be provided for the turning operation on the machine. You have to write the G code by using the milling machine, and simply we have to make something similar to this one. I tried to make a similar drawing as much as possible. Then you're going to follow the same tutorial to write down your own code. We have some example here similar to the one we had in the class, and we covered in the class, and as you remember that in the case of the G coding for the turning operation, we don't have to do the Y direction. The only directions we are going to have is going to be the X and the Y. Sorry, the X and the Z. Actually here we have an example code for making the chest pound. Now chest pound difference is that we are going to have the collar and we have the spherical head instead of the cylindrical one. Of course, it's going to be shorter and it's going to be narrower from here. So actually we are going to do a code for this one. It's going to be more simpler than the code we have here, but still we can use this code or part of this code to do our work. For example, at the beginning, for the definitions we are going to have for the G18, G40, G49, G90, G94, and G80, it's going to be copy and paste directly. M0, M3, that's when you are going to start the motor. Then we are going to do the cutting operation. Now, as you can see here, that usually we are going to have X, we are going to have Z. So let's analyze the work before we start to do the programming. Basically, what we are going to have at the end is going to be this shape. The total height is not showing here. The total height of this part is going to be 50 millimeter. Let me see if I have a clear image here. Yes, okay. Now, so the part itself is going to be total height of 50 millimeters should be remain after the cutting. To have a different codes for every student, we are going to have this simple equation. The total height is going to be 50 minus SPQ. SPQ are the from the right is going to be the first 3 digits from the right. So it's the last number, the number before, and the number before in this student number. So for example, if you are going to have well, let's say, okay, now if your student number is 1, 2, 3, 4, 5, 6, that means that the SPQ are going to be the 4, 5, 6. So to find this height, you are going to have 50 minus 0.50 minus 0.456. 0.456. This will be the total height of the work. And I suggested that this base diameter is going to be 30 minus the SPQ. So it's going to be 30 minus 0.456. And for the top cylinder is going to be 24 minus the SPQ. Okay, and so on. So this is just an example for the dimensions you are going to have. Obviously, if you're going to divide this one to make the total of the calculation is going to be equal to the 50 minus SPQ, we're going to I suggest that this one is going to be 5 or 6 millimeters, and this one is going to be 21 or 23 minus SPQ. and this part is going to be 8 millimeter, and then we're going to have a radius of 3 millimeters. Then we're going to have this equal to 8. So the addition of this side of all the heights is going to be equal to the reason height. Now, if you would like to do the machining, I'm sorry, I have to close that. If I would like to do the machining, as you remember, once again, I have to sketch half of the work. Now, simply because in the operation of the milling, of the turning, I only have to remove the material from one side, and then it's going to be removed from the other side as well. Because the part is rotating, symmetrical part at the end, so I only have to remove from one side by inserting the cutting tool to a certain depth of cut, and this will make it equal to the same on the other direction. Well, specifically, if I will have the 31 millimeter diameter for the stock material, if I'm going to insert the cutting tool for 0.5 millimeter from the radius, that means I'm going to reduce the diameter by 1 millimeter, because 0.5 millimeter from each sides, from the top and the bottom, because just keep rotating, and this will make it 1 millimeter in total. Now, as you can see here, that I divided the the top line as the line for the stock material. I start to remove it by layers, and as you can see here, that I'm going to have multiple layers to be removed this shape, and at the beginning I'm going to have this step shape for the cutting. This is what we call the rough cutting. Okay. And then in one shot we are going to do the curve, straight line, table shape, another curve or arc, another arc, another arc, then we are going to continue to do the cylinder, bottom cylinder. Okay, now I will consider that this point is going to be the 0 point for the Z and the X. Everything, if I'm going to move in the right direction, is going to be positive Z value. If I'm going to move on the left direction, this will be negative Z value. Now for the X, it's tricky because actually at that point I'm not going to tell the radius, I'm going to tell the whole diameter. So if this one, from the height from here to here, is it 12, actually I have to specify this point exactly where the where you can see the mouse are, is going to be the X going to be 24. It's not 12. The radius is 12, but I'm going to mention the diameter. And for the Z value is going to be 0. If I'm going to push it backward to this position, the X will remain as 24, but the Z value is going to be equal to minus 6 when we choose the 6 or 5. So it's going to be minus 6 for the Z value. So the difference between the turning and the milling, in the turning, the cutting tool or the cutting path actually is not going to be offset from the work part. It's going to be directly on the work part, because there's a direct contact. We don't have rotating cutting tool. Now it's rotating part. So the cutting tool tip is going to be the position is going to be the position of the cutting path at the same time, or tool path as well. So before I get to explain to you how to write the code, let's try to sketch the part on SolidWorks, and from there we will be able to find the X and the Y value, the X and the Z value. So this is the X and this is the Z. So it's better to choose the top plane to sketch on. I'll try to do something similar, and obviously I'm going to make, well, it's telling me that this is the Z direction, positive direction, and this will be the positive X direction. So the best thing to do it is like that. Okay, so I'm going to find my 0 point, and this will help me to indicate no. once again. Yes. Okay, so everything is going to give you the X and Z coordination for the work part while I'm doing my work. So now let's try to make a line. So this will be the 0, 0 as you can indicate in this position. So this is my 0, 0. It's much better to put exactly at the center. Then I'm going to sketch a line. Okay, and X, Y. Okay, I'm going to click horizontal line 100 degree. I'm going to take this one to 12. Now in your case it's going to be 12 minus the PQR divided by 2. Now if I'm going to find this position, this will tell me the location of the X is going to be 12. Now from here I'm going to sketch a line. Let's say it's going to be 6 millimeter. Make this one as 6 millimeters. Okay, now the coordination of this point is going to be 12 for the X, and the Z is equal to minus 6. Now I think I forgot something, because actually we need to do the face cutting for the part. So I'm going to make well, I'm going to leave it 0.5. Okay, I'm going to make this, going to change something, and I'm going to make this one as 9. I'm going to make it as 7. I'm going to remove 1 millimeter by the face milling. Okay, so this will be position number 1. Now it's better to sketch the whole part, and then I'm going to do the cutting on it. So you remember that the stock material was for the height, it was 31 millimeter, and if I'm going to divide this one by 2, it's going to be 15.5. so I'm going to make this line as 15.5. okay, and it's better to change it into construction, and for this height I should make it as 50. In your case it's going to be 50 minus the SPQ for construction. Okay, let's change all the lines to construction line. Okay, so these lines are for construction. Okay, now the dashed line represent the stock material, and all the blue lines, continuous blue lines, are going to represent the part material. So obviously at the end we said we are going to have the 30 minus SPQ. In my case I have to make it as 30, and this will take me to 15 millimeter for the base diameter. Then I'm going to take this one to, let's say, 10 millimeters. I think 10 is too much, so I'm going to reduce this one. Now let's make it as 8. Okay, and let's have a straight line. We are going to remove it later of 50 millimeter. That's the base, that's the top. Okay, I'm going to make it a straight line just to indicate what are the shapes we are going to have. Now I need to connect both, so I'm going to take a look at the shape once again. So now this one. Okay, now take a look at the shape. What we have is the top, then we're going to have the fillet here. So let's try to make this fillet first. We consider it going to be 3 millimeter. If this one is going to be 24, I'm going to reduce this one to okay, so I have to make this part is thinner by certain value, and let's say it's going to be thinner by the top one was 24, so let's make this one as let's say 20. I'm going to make it as 18 and try to figure out. So this will be 18, and I'm going to make well, this basically says going to be 30. Oh, we don't have a okay, so I have to cut this one later to a cylindrical shape. So just let me check that once again. Yeah, and there's a color in the middle. So I think this will make my life a little bit easier. So anyway, so let's try to make another cylinder at the bottom, which is going to have the 18. Let's make it 8, or I'm sorry, 9. Oh, is the line? I'm sorry. It doesn't appear, so just undo. Oops. I'm sorry. This line should go back once again. 12. Okay, and I'm going to make a part which has the 9 millimeter. Okay. Now that's basically the things. I'm not going to continue with that. Sorry, I'm not going to do it like that. I have to do some modification on it later, because it shouldn't be a straight line. Now I need to make a fillet here, and consider that the fillet is going to be 3 millimeter diameter, and I would like to have, for example, a taper shape. So I'm going to increase another 3 millimeters here. So 1, 2, 3. Okay. Then I'm going to sketch a line from here to here. Okay, and I'm going to remove this line. Okay, now this is acute corner, so I'm going to make this one as a circular fillet. So the best thing to do that is I'll consider that this is a 3, well actually this is 3 millimeter. So I'm going to sketch another line with have 3 millimeter. Make this one as 3. Okay, and then I'm going to make a center point arc, and this will be starting from here. I'm going to stop when it's going to be in contact with this spot. Okay, so I made my fillet. Now I made my fillet. I don't need this line anymore, and I have to remove the unused part here. Okay, and actually I don't need this one as well. So I made the top. If I can take a look on this one, I made my top cylinder. This will look like that. I'll go back once again to the same position to complete the rest. Now for the bottom, of course, you know, I don't need this part, so I can simply trim it. And what I need is how to make these parts. So we should have a collar here. We should have a cylindrical part here. So let's try to make a cylindrical part by try to fix this one. Just take a look at the shape once again. You can see that this table shape, collar, another collar, cylindrical shape with the collar. So I would like to make cylindrical shape here. First I have to make the collar, so let's sketch something from the base here, and let's consider that this height is going to be 2 millimeters. Well, let's make it 1.5. Okay, so I will have this one as 1.5. It's went to the other direction. Undo. So redo the work. So it's much better to make it as a line. So this will be 1.5. Okay, then I'm going to sketch another line to here. Okay, now I will keep this one. This will be the base color, as you can see here. Now the only thing I'm going to make first is going to be this pumping out arc. So let's consider that this one will start from here and going all the way to here, but the radius will remain the same. So let's start to sketch another line. So I'm going to finish this circle to the half. Okay, the total is 6.5, so let's go to 3.25. 3.25 up. Sorry. Then I'm going to move in this direction for another. Let's say it's going to. I'm going to make it try. Let's make this line as 4. And I'm going to use this point as a center for my arc. Well, this should be I think this should be good. Okay, I'll keep this one first. Okay, now I would like to make another part here to take this one up. Sorry. Okay, so I'm going to remove this one. Now just remember what we have done here. We used this one is 3 millimeters, so this one was the center point of that. We went down for 3.25, then we went to the side to 4 millimeters to find the center, and we sketch this curve. Okay, now want this one to come up a little bit as a curve. So let's try to find something. Maybe we can use simply again to make another center line. Take this one to, let's say, 2 millimeters. 2 millimeters, and I'm going to use this point as center for my arc. It's going to connect this line by this line. Okay. Well, sorry. Undo. Let's try to find something more suitable to get the shape look like that. This will go up. This will go 24. Now maybe I need to modify something. Let's try that once again. It's an arc. It's going from here to I didn't like the shape, so the best thing is to do the following. I'm going to repeat this process. Shorten this one to, let's say, 2 instead of 4. Now this will take it too much. Well, maybe we can do something like that. Okay, now yeah, well this one is more suitable. This arc is going to be more suitable. Okay, now I made it as 2 instead of 4, but now I get to remove it anyway. And now let's try to do another arc to make these spots. Okay, remove unnecessary parts which are not going to be used. Then I'm going to make another collar here. So the other collar is going to have the radius of 1 millimeter, 2 millimeters. So I'm going to take this one for 2 millimeters. Sorry, yeah, 1 millimeter. Then I'm going to make it horizontally for 1 millimeter. One. And I'm going to use this one as a center point for my arc. Okay, and stop here. So now I'm going to remove all the lines that I'm not using. This one, that one. Okay, so I'm going to leave this one. Maybe it's not going to be exactly what I want, but anyway, let's do it this way now. It's not going to be wrong, but I think that the cutting tool will not be able to go this far. But anyway, now we have the basic shape, and if I simply going to revolve that around this axis, it's going to give me the shape of the pound I would like to have. And let's try, I don't need this line as well, so cut this one as well. Oops, undo. Oh, okay, so I remove this part. Now if I would like to revolve that, simply do the revolving, evaluate features, revolve boss and base. So this will be the, I have to have a solid line here to make this a process, so just make a solid line. Okay, and now I'm going to do the revolve process for this part, and this line of rotation will be that. Okay, and 360 degree. Sorry. Line 27, and this one will be this region. The features off. Actually, correct. The contour is region 1, and that means that the body is not complete 100%, and that's what create the error we have here. But anyway, I'll try to solve the error. Start from the beginning. Let's remove the outside thing. So that will be the part we are going to cut. Now maybe it doesn't look like the one we have on the photo by 100%, but at least can do the job. Okay, less details. That's going to be the work you would like to have. Now the only thing you have to do now is to follow up the same steps. You don't have to generate the solid shape because you are not going to do any CAD/CAM. The only thing you are going to do is you are going to use the shape to find the points. Now I will go to the shape once again, and actually I'm going to delete the revolve. Exit. Delete the revolve. I don't need a revolve. I need to go to the shape itself. So that's the shape I'm looking for. And just remember that if I'm going to put it this way, by clicking on any point, it's going to give me the value for the X and the Z, and that's what I would like to have. Okay, you can see that the Z is -7, the Z is -9, the Z is -36, the X is equal to 1154. Another point where the X is equal to 30, X is 1173, and the Z is equal to -38.85. The Z is -42. The X is 12.82, and actually we don't need this point. I think there's an extra line need to be removed later. But anyway, let's say well, I'm going to fix this one. Actually, I didn't like it. So maybe I'm going to stop it to a certain place. I'm going to make another line here to fix this situation, because actually what will happen that the cutting tool will not be able to enter this area, so I have to modify it before I get to do the programming process. Okay, now let's try to fix this one. I think that the best thing to do is to make another arc here. So that's good. We have an indication here that this is the midpoint for our line here. So from the midpoint, I'm going to sketch a line and make a circle. So let's make a line here. The total is going to be 0.7. So let's make it at let's say 0.3 is too low, so I'm not going to use this point here. So from here I'm going to sketch a line. Total length here is 2.18 at 1 millimeter. Well, actually this is in the 0.1 meter. So at 0.5 millimeter. .5, and I will go for another 0.5, and I'm going to use this point as a center point for my arc. I'm going to sketch an arc. Let's start from here. Okay, now just take a look exactly to what I had. When I start to have this line appeared, this line, I'm going to have a contact from here and ending when the light is going to be bright. That's okay. Then I have to remove the lines I'm not using. This one, that one. Okay, now maybe we had less color here, but I think this will do the job. Because actually we're not testing you to have an accurate shape. The most important thing for me is to check your ability to write down a code for using the G coding in the turning process. Okay, now that's the part, and now I'm going to sketch the stock material. Oh, sorry, I have to change this one because we're not going to start at 0. I'm going to reduce this one by -1 millimeter. So go to 1. Sorry. Undo. Oh, let's do it on the bottom, because actually this should be construction line, because actually we're not going to use it, and this one will be a construction line. And from here I'm going to sketch -1, 1, and from the 1 I'm going to go to top here. Okay, so that's mean this part will be unused. This will be removed. Okay, so I'll take this line. Oops. Sorry. Remove that. So this will be the shape we're going to have. It's going to be shorter, and the height of this line is going to be the 15.5. And then I'm going to sketch another line which equal to 50. For your case, going to be 50 something. Okay. So for construction, finishing 0.5. Okay. Sorry. Now these lines are for construction. That means it's going to be the envelope of the stock material. Now the outside, the dashed line from the outside is going to be the outline of the stock material, which is the cross-sectional of the half of the cylinder we are going to have. Okay, and okay, now if I'm going to explain that to you, well, let me explain that to you. Let's try to do the revolve. Long-term revolution. Cancel. No need, because actually you understand what we're talking about here. I'm not going to use this one. Now let's try to find the points which is going to help us to write down our code. So this point is going to be my 0x 0z. If I'm going to move toward the red line, the red arrow in this direction, this will be the value for the -z. Everything to the right side is going to be the positive z. Everything to the top is going to be positive x. But just remember that in our case we are going to use the diameters, not the radiuses for the part. So if I get to well, you know that this line is 12 and this point is still a straight line. We know this arc, we know this point and this point, so we can sketch the taper cutting. Then we're going to have an arc here. Now this arc is going to be clockwise, this arc is going to be counterclockwise, another clockwise, another counterclockwise, clockwise, and then we're going to have a straight line cutting. Now the problem is that in all the cases we'll not be able to do this cut directly because the depth of cut is going to be too much. So what we have to do is I'm going to save that sketch and sketch on top of it. Now it's going to be a good idea at this position to take the diameter, the dimensions for these points. So this one is the x is 12 and the y is equal to sorry, the z is equal to -1. I will record that. Just give me 1 minute. I'm going to bring a pen. Okay, so I'm going to record this position. So I already have the drawing, so I'm going to draw one, new one, which is going to look like the same. Make an arc because actually it's different from the one I just showed you earlier. And an arc. Then we had another arc, the fat one, small one, and the base. Okay, so I'm going to sketch the same one on paper, but I'm going to record these points on it. So this point is, I'm going to call it 1, the other one is 2. So point 1 is going to be where the x is 12, the z is minus 1 millimeter. The point 2 is going to be equal to 12 millimeter, and the z is equal to minus 7. The point 3 is this point, and in this case the x is equal to 9.17 millimeter, and the z is equal to minus 9 millimeters. So you're only going to write as P1, you open bracket, then you put the x comma the z. Now we go to the point number 4, and in this case the x is going to be 11.54, and the z is equal to minus 36.68 millimeter. The P5 is x is equal to 11.73 millimeters, and the z is minus 38.85 millimeters. The P6 is where the x is equal to 12.82 millimeters, and the z is equal to minus 42.0 millimeters. The point 7 is going to be 14.09 millimeter, and the z is equal to minus 47.62 millimeters. Point 8. Now we may expect that this cutting is not going to be so accurate, because maybe the cutting tool will be bigger than that, is going to hit this side. But anyway, we are going to continue with that. The P8 is equal to the 14.25 millimeter, and minus 48.5 for the Z. And last, the point 9 is going to be equal to the 15 millimeter for the X, and minus 48.5 millimeter for the Z. Now just remember that we're reading the values from here. Okay, now we got these dimensions, and actually the first cut is going to be as following. So once again, I'm going to use the same plane to sketch. Now my first cut is the face cutting. In the face cutting, I'm going to remove this block. Much better to make it as rectangular. So I'm going to remove this amount. Now, how to do that? Now, the process is going to be as following. If we're going to take a look to the code we have, the sample code we have, so we are going to copy the same steps and paste it. Let's start to write down new code on the page I have. Okay, so just copy that. This will be the first line. The M3, second line. Now, I'm going to move my cutting tool to the position where, now just remember, at the beginning this area was filled with material. So I'm going to move the cutting tool by writing down the code. It's going to be G00, where the X is equal to, now the maximum was 31, so I'm going to make it to the X 31.5, and the Z is equal to 3. So my cutting tool head is at this point at the moment. Then I'm going to go to G00, where the X is equal to 31.5 and the Z is equal to -1. No, not -1. We're going to feed it from this direction. Okay, yeah, let's make it as -1. Okay, and then I'm going to do the G01 to the X is equal to -1. So my cutting tool, it was in this position first. I'm going to take it in this direction, then I start to feed it to the work part until I'm going to reach the -1 for the x-axis. What's happened is I removed a layer from the face. I think I had a video for that. It's going to be a good example for what we are going to have. Okay, now it's doing the cut. This is starting the process. Now you can see it start to move the material step by step and then start to do the finishing cut, and that's what we are going to do once again. There's the collar. There's the finishing cut. As you can see that the feed rate has been slower but the speed is became faster until I get to have the final shape. Now you can see that in this side we have some material need to be removed, and that's what we're going to remove with the face turning. Okay, now this is the face turning. Just remove a layer from the face to shorten the part. Well, actually, for in our case, we're going to finish it till the end. Now, this is another process of the cut of the face. Now, this is a milling, cutting on the turn milling machine. Actually, we are going to get this one. We saw the profile cutting in the turning operation, lathe operation, and we saw the face cutting, and this is the most important thing for us. Okay, let's go back to where is the file was open. That's the file. Yeah, that's the file. Okay, so by doing the first stage, which was the face milling, I will go to the diagram we have. I think it's much better to copy this one. Okay, so I'm going to copy this diagram. Okay, so okay, so we do the face milling. So I'm going to write down that this is a face, face turning. So the first step is G O O, and I'm going to take it to where X is equal to 31 and Y Z is equal to 3. Then I will go to I can write down the GO once again, GOO, where the Z equal to -1. Now in your case, the Z value is going to be what you decide is going to be the 50 minus the point of something. So that's what we are going to remove, actually, the point of the SPQ value, and that's how we are going to go further for in the negative Z direction. And then we are going to do the actual cutting G01, where the X is going to be equal to -1. So that's means that my cutting tool will start the cutting here, actually in this level, from the face turning until we're going to reach this point. Then we're going to leave the part. So the next step is going to be the G00, and we can, for example, go back to the same position we were at the beginning. Copy and paste. So we just did the face turning at the beginning. Then we're going to start to remove the material, as you can see here, for the X1, X2, X3, X4, X5, 6, 7, 8, until we're going to have the step shape preparation before we do the finish cutting. Okay, now to refine the code, we are going to start doing the one in the highlighted. So the pro is going to be the facing off. The tool is going to be tool number 1. We go to the point where the X is equal to 30. Well, this one should be 32. So I'm going to do this one 32, and the Z is going to be 10. I'm going to do that 3. 10 is too much. Okay, let's make it something in the middle. So let's say it's going to be 5. Then we have to choose the G96, the M04, and the spindle speed is going to be 175, and the G99 and G20 -1. If I get to go deeper, -1. In your case, as we said, is going to be the value for the X, the SPQ. And then we are going to go to do the cutting using the feed of 0.05, and then we are going to go back to the position where the Z is going to be equal to 1. That means we do the cut, then we go back once again, leave the part. That's what we do actually in the turning process. Each time we do the cut, we have to leave the part and we go to a new position to do the work. Now the second step is just to remove a certain layer from the stock material to have the designed diameter we would like to reach. We're going to take it from the 31 to 30, and once again your case is going to be 30 minus the SPQ. So I sketch this line starting from the beginning where the Z value is equal to -1 until I'm going to finish where the Z value is equal to -50. Now if I'm going to take the coordination of this point, I can see that the X value is going to be equal to 50. So actually that means in our case the X will go to the double value, which is going to make it 30. Now just remember that all the points we had earlier, you have to multiply the X value by 2, because what we got was the radius, but we dealing with the diameter. Okay, now for this point it's going to be 30 and the Z value is equal to -1. So I can sketch, write down the other code. So it's going to be the G00. I will go from where I start now. I just my position actually was where the X is -1 and the Z is equal to 1. So I will go up to the top, or maybe I can go to the same position we had earlier. Then I'll get it closer to the work, so I will go to x is equal to 30, and well, actually this is 31. Anyway, x 30, and z will remain as 1. Then I will go for the GO 1, where the z is equal to minus 50. Okay, now with this process, I just simply cut, starting from this level, this point, and then I went all the way until I reached this point. I'll just remove this layer. Now I will do the same for all these positions until I get to reach this edge. Now here I don't want to have I cannot have these curves, so what I'm going to have is going to have step cutting. So actually the shape of the cutting next is going to be as following. Let's say I'm going to stop at this point, going down, let's say by the depth of cut of, I think that we can go for 1 millimeter. And go down for 1 millimeter. It's better to leave it here. Then let's say start from here. See if I can go for 1 millimeter. It's going to be too much, so I'm going to go for 0.7 or 0.8. Actually I should see from the other side, because well, let's start from this side. Yeah, well, that's nice cut. So by the same method, when I removed, well, is it horizontal? Yeah, it's not horizontal. So I'm going to sketch another line. It's going to be horizontal. No, horizontal is not going to work. Because obviously the horizontal will cut the part I don't want to cut now. Why I can't see that this one is a horizontal? Anyway, let's try to do this one as a horizontal line. Just want to check. Is that horizontal? Oh, sorry, it shouldn't be horizontal. It should be vertical, because we're looking in the other direction. Yeah, it's went there. So actually, I'm going to remove that and make it as a vertical instead. Yeah, so this one is not going to work because this will cut the part I don't want to cut, so just simply delete this line and delete this line as well. Okay, so I will go with the further step. I don't want to cut this part now, so I just want to go one layer beneath. Let's say it's going to be 0.75, 0.76, and 0.7, sorry, 0.76, and from here I'm going to make a straight cut to here. Okay, now this depth is going to be 0.23, so I'm going to make another cut. That's going to bother me now anyway. Okay, and I'm going to stop at this point. Okay, then I'm going to do the internal cuts here. So I'll go, for example, for the total is 0.46, so let's go to 0.4. 0.4. Then I'm going to make a straight cut till here. Oh, that's 0.38. Actually, I choose the 0.4 here. Point 4, and this one should be 0.4 as well. Okay, and now I'm going to do another cut, and this should be, for example, starting from here, 0.4, .3, you can choose these things randomly because we're going to remove the steps we're going to have later with the table cut. Okay, so every cut we call a pass, so we are going to have multiple passes here to do the work. Okay, so these are the passes we are going to have multiple passes as we saw in the video. At the end, I'm going to have the stepped cut, and later we are going to do the cuts for the curves until we're going to have the finished part to be done. So now we're going to write the second line to remove this area. Okay, so I'm going to start. The depth here is going to be the 14. That means the x value is going to be 28, and we repeat the same line but with 28, and then we are going to stop at the z equal to minus 42.11. So we go to the code, we can simply copy and paste the same thing. Well, okay, well, just to reduce the number of the cuts we are going to have, I just reduce the passes we have, because I just remember that we are going to have the angle for the cutting tool, and this may damage my work part in this stage. So what I did, I just push my passes to the side to do all the cuts for the before again preparing for the arc cut and for the table shape cutting. So now number of the cuts we are going to have beside the basic one, that's 1. So sorry, face is going to be 1, one layer to be removed, the second, third, fourth, fifth, sixth, seventh, and the eighth one. And if we're going to count that, we're simply going to find what will be the diameter at each time. So the original diameter, we assume it to be as 31. Then the second cut, the first cut is going to be with the depth of taking the cutting tool to 30. The third one is going to take the cutting tool to 28. Then take it to 26, sorry. Take it to 1246 and 24. Sorry, this one, yeah, 2446 and 24. Then we are going to start the cut from this point, where the Z value is going to be minus 8.15, and the X value is going to start as 22.46. The third one is going to start from the X is going to be 21.12, and the Z value is going to be minus 9.2, and the last cut is going to be for the X value of 19.62, and the Z value of minus 10.27. So if I'm going to number the cuts, it's going to be from 1 to 7. Just check if I missed something. 1 is the first to take it to the diameter I would like to have. 2, layer 2, layer 3, layer 4. Oh, I missed 1. This will be layer 4, layer 5, the thin one, layer 6, layer 7, and layer 8. So I'm going to remove these layers before I'm going to remove the step shape by doing the final contour cutting. Okay, so once again, to take the data for each point, where you are going to start from, which level you are going to start at, you just put the mouse there. For the X value, multiply this figure by 2, and this will be the Z value. And the same thing for here, 28 for the X, the 20, let's say that this one is going to be 26, 24.48, and 24. Where to finish at is going to be the Z value at the end. Again, to finish at minus 42.11, we finish at the minus 41.63, we finish at the minus 41, we finish at minus 36.66, we finish at minus 30.45. Remember here that we are going to start from minus 8.15. For this one, we are going to finish at minus 24.9. We start at minus 9.2. This one we finish at minus 15.42, where we started at minus 10.27. Now, how to transfer this one to the code? So I start to write down the code once again. So we start at the X is 34 and Z is 2. Then I go to the X is equal to 30. Then I go to start the cut till Z is equal to minus 50, with the F is equal to 2.2. Then I go to take the cutting tool away from the part to the point where the X is equal to 30.2 and the Z is equal to minus, let's make this one 30.5. Okay, and the Z is equal to minus 49. So we just pull the cutting tool and we push it back to where the Z is equal to 2. Then we are going to drop the cutting tool a little bit lower where the x value is going to be equal to 28. So in this case we are going to remove 1 millimeter from one side, and this will reduce the phi by the diameter by 2 millimeters. So we are going to go to do the cut from this level of the x till the z is equal to 42.11. Now we are going to take the tool away from the finish from the end point to the value where the x is equal to 28.5 and the z is equal to minus 35. Then we go back to the point where the z is equal to 2, drop the cutting tool deeper, then we go to the value of the z is equal to minus 41.63. Then we go up a little bit. Well, just remember this x value, you go up by 0.5 millimeter, and then you go away in the z direction to the right. Go to z equal to 2, x 24.48, the g as z equal to minus 41, and then go to the depth of the x is equal to 25, z is equal to 35, and then you are going to go to the z is equal to 24, do the cut to the z location of minus 36.66, and then we go up and to the right, then we go to the GZ2. Well, actually we're not going to be GZ2 in this case, because I would like to do the cut for this part. So I'm going to go where the z is going to be equal to minus 8.15. Okay, so this will be 8 minus 8.15. Okay, then I'm going to drop the x value to 23.2. Okay, so the x value here is going to be 23.2. And then I'm going to start the cut until I'm going to reach the z value is equal to minus 36.42. I will leave it as 0.35. Doesn't matter. Okay, then I'm going to go to 23.7. I have to take the cutting tool out. So x is equal to 23.7, and the z is minus this one is worth 36, so I'm going to take it to, let's say, 29 for the z value. Then I will go to the next point where the z is equal to, in my case, this one, minus 9.2. Okay, so z is equal to minus 9.12. Minus 9.12. Okay, then I'm going to get the cutting tool deeper with the cut. Okay, I think that yeah, here I inserted the cutting tool, so I have to put G1 here, no G00. G1. Okay, G1, X, go to Z, G1 where the X is equal to 22.4. Then I will move the cutting tool to the value of the Z of minus 30.45. Sorry. Well, I have to check that because I use the old figures. So here the 22.46. I use this figure. 22.46. 0.5. Okay, Z is 36.5. Let's check if this is correct. Oh, sorry. 24, we finish at that. 24.5. Z50, Z 0.85. gx 22.46 22.46, and we finish at the Z value of 30.45. Okay, then we go up, and then we are going to go to the Z 9.12 and go for the depth of 21.12. Okay, 21.12. Okay, then we are going to do the cut till Z is equal to 24.9. Minus 24.9. Then we go a little bit away where the x is going to be equal to 22, and the z is equal to 27 minus 27. Okay, now I have a last cut here, minus 10.27, and this one is 9.81 times 2, so it's going to be 18 plus the 1.6, so it's going to be 19.6 for the x, and the z is minus 10.27, and we're going to finish at minus 15.4. Okay, so we go back once again. I'm only going to repeat the same process, so I'm going to copy from here, copy and paste. So from here we are going to go to that, sorry, I just want to do that. Okay, so we go to the z value of minus 10.27, minus 10.27, and the x will go to the depth of 19.6, and we finish at the z value of minus 15.4. Okay, and then when we are going to finish, we are going to go where this x is going to be equal to, let's go to 22, and the z value is going to be minus 10. Sorry, this one was 10.27, so we should go to let's say it's going to be well, let's take this one higher, and this will solve the problem. 24, and take this one to, let's say it's going to be 15, 16, 12. Okay, so we do the cutting tool away. Maybe I'm going to make it as 24. Is that okay? Now we take it to this point. So actually, after we did these cuts, the shape we are going to have at the end is going to be as following. I'm going to remove all these lines. Okay, so that's the shape I have at the moment. This dashed line. Now I would like to remove it, so it's going to be a very simple process where I'm going to start the cut. By the way, we cut this one earlier. Okay, then the final cut I would like to have is to remove these parts. So I'm going to start the cutting from here to make an arc, taper cut, an arc, another arc, another arc, another arc, then straight line. And I know at the end we're going to have this one will look like an arc because the cutting tool will not going to be able to do this cut. So actually the process now is going to be very simple because I'm going to bring the cutting tool to this position. So finish with this one. I'm going to close this sketch and I'm going to deal with this one. First, this point is the X is 24 and the Z is equal to 14. So 24 for the X and the Z is -7. I'm going to move from this point to this point. Okay, and this will be the final point. So the X is going to be 18.34 and the Z is equal to -9. Take this point, it's going to be for the X 23.08 and the Z is equal to -36.68. This one, we're talking about the X value is equal to 23.46 and the Z value is equal to -38.85. Now this point is 25.64 and the Z is -42 millimeters. This point is going to be 28.18 and -47.62 millimeters. 28.5 -48.50. This point is going to be the X30 and the Z is -48.5. Now the arc of this one, the R, is going to be 3 millimeter. So between point 1, point 2, we are going to have the G02 with the R of 3. Okay, so point 1 to point 2, G02, R3. Between 1, 2 and 3, just a straight line. So G01 for P2 to P1. From P3 to P4, now this will be a counterclockwise arc, so it's going to be G03 and the R is going to be equal to 1.47. Now this is a clockwise cut between the point 4 to point 5, so G02 and the radius is equal to 2.11. Now another G03, P5 to P6 with the radius of 3.51. Another arc, P6 to P7, the R is going to be equal to 0.56, and this will be G02. Okay, then P6 to we will just take in the cutting tool out, and this will do the work. Okay, so when we reach this stage, now I would like to do the arc process. So first I'm going to do the G00 to G0. That will be enough. Okay, to sorry, this should be G0. Okay, so G0, where the X 24 and so it's going to be 25 first, 24.5, and the Z is equal to minus 7. Then I get to go to G01 where the X is equal to 24. Then I get to go to G02 where the P is going to be to P2, because now we are at P1. We go to P2, which is the X 18.34, and the Z is equal to minus 9 with the R value of 3. Then G01 from 0.2 to 0.3, so we go from the recent location to the other location of the 0.3, which is equal to 23 point, sorry, X 23.08, and the Z value is equal to minus 36.68. Okay, then I had to do the arc cutting once again from 3 to 4, but this one is going to be the G03. G03 from recent location to the other point, which is P4, 20x 23.46, and the Z is minus 38.85. Now G02 once again, that will be from the point number 4 to point number 5 with the arc of 2.11. No, sorry, I forgot to put the arc here. The radius here was 1.47. G02 to the X. Now these are position for number 5, point number 5, 25.64, and the Z value is going to be minus 42 millimeters. Okay, and the R value is going to be equal to 2.11. Now another G03 between 5 to 6, G03, and I'm going to use that the X, the final position I would like to go as the position of the point number 6, 28.18, and the Z value is minus 47.62, and the R value is going to be equal to 3.15, 3.151. Okay, and then the G02 where the X is equal to, that's point number 7, 28.5, and the Z is equal to minus 48.5. Okay, then we're taking of the cutting tool G0 where the X is 30, then you go to the Z is equal to 2, then you turn off the machine. So you did the whole cutting, and you will get the final shape, which is going to look like the following. Sketch 1. Okay, okay, so if I'm going to remove these lines again, undo the last cut. I'm going to change this one into solid line, revolve. I'm going to have this shape. Okay, so try to work on that. Prepare the code, put on the Word document, take your laptop with you so you can simply put it on a text file later, and in the lab you're going to run it to make this part. Okay, so that's it for today's tutorial, and if you have any questions, just drop an email.